basic science for a year, and then they start performing relay operations and perform relay operations for any lander that's on the ground. Thanks. This is a pretty good indication of just how far we've come. Mariner 4, 1964. First spacecraft of the United States to successfully fly past Mars. There's a picture taken from the Mariner 4. Mars Reconnaissance Orbiter, picture taken in 2006. Lots of detail. This is done from an altitude that was about the same as what the Mariner 4 landed, but you can tell with the high rise how much greater detail you have. And then you've got Phoenix, which has the same cameras as the rovers on it. And there's a picture from the North Pole of Mars. Next. Okay, are there any questions? Yes.
In designing these transceivers, how much more difficult would you say is it to deal with the thermal constraints, cold cycles these things have to be designed to tolerate, than say a transceiver to go on an Earth orbiting satellite?
Well, it's interesting. Earth orbiting satellites are actually, except for radiation, a more benign environment. The temperature swings aren't as wide. Mars, especially like with Phoenix, could get down to below 100 degrees, minus 100 degrees centigrade at the poles of Mars at nighttime. Our test specifications are much larger temperature swing for a lander than they are for an orbiter. A lot of it has to do with the heat getting conducted away during the cold time, but you're insulated also, so you can get a problem even though you're in an environment that's minus 55 degrees below zero. Inside the actual body of the lander, it can get considerably hot, maybe 60, 70 degrees. Yes?
What's the output power on your transceiver that you showed?
10 watts, less than a refrigerator light bulb.
Are you hermetically sealed on those units?
Well, the radios themselves are not hermetically sealed, but the parts inside of it are.
How do you get rid of the heat?
Well, part of it's conducted out. We literally bolt them down to the chassis, and that chassis conducts the heat away. The chassis of the vehicle that you're on.
What's the frequency of your transceivers?
Am I allowed? Okay. 401 and 437 for the 502, 505 series. The MRO can operate anywhere from 395 through 450 megahertz in any of those frequency bands. Yes?
Go ahead.
Do you have some built-in redundancy, or otherwise how do you deal with reliability of electronic parts?
We spec high reliability parts. We give them a very rigid test system. The redundancy, especially since MRO, is 2 radios per spacecraft.
How much harder is it, or how much more difficult is the radiation environment for hardening these radios for Mars or outer planet missions versus Earth orbit? And it's not really related, but do you run into any ITAR issues for international participation with communication standards?
Oh, yes. That answers the second part. The first part is actually at Mars you've got less radiation. Because of the radiation flux, you're spread. Mars is twice the distance from the Earth, so the radiation flux goes down by the square of the area. So it's literally 1/4 of what you would encounter in Earth orbit.
Let's say 20 years from now we have human explorers on Mars and they're out poking around near one of the spacecraft that has some of your hardware on it. What's the probability you think that they could pull off a transceiver and fire it up and still be operational?
20 years from now? Well, since the batteries would be gone by that point in time, the temperature extremes are very hard on solder joints. So the parts might be okay, but the solder joints would have failed. So you wouldn't be able to get power in or power out, or Lord only knows what the mechanism would be at that point in time.
What do you guarantee? Or I guess it depends on the spec of that particular spacecraft.
The rovers and Phoenix were 90-day missions, and now we're 6 years later, going on 7 years. Spirit would still be roving today if it hadn't got stuck in the sand. Opportunity's still doing quite. Opportunity passed Viking. Viking had a radioisotope power source in it, and last May it surpassed the Vikings record. Any further questions?
Yes,
Yeah.
how much memory can this hold at, say, at one time? Is it variable? Or is it?
Do you remember?
The electors have quite a bit.
Yeah, I don't remember exactly.
Hundreds of megabytes.
And what language? I was curious, did you write, somebody write the language?
It's not language, it's development code for the field programmable arrays inside. It's not really a computer in there. It's got aspects similar to the computer, but it's not a computer because it's hard to get radiation hardened computers.
More like a microcontroller. Everything's done.
Yes, that's pretty close to it. They're called state machines.
What was that? I didn't hear what
Your hardware is not for the primary data storage on the vehicle. There's other,
Right. There are other storage mechanisms. There's a firmware and RAM and flash memory that store the data, and then that in turn gets transferred to the radio, and the radio transmits it to the orbiter. The orbiter transmits it to Earth. One of the DSN networks will then send it to Cornell University, which has got the primary science responsibility, and they will do the analysis.
Do these radios continually operate?
No, they only operate during passes of the orbiter. What happens is the orbiter will be coming around and knows where the rover is located, or the lander, and starts transmitting a signal. Do you have anything for me? That receives a transmitter and says, yes, here's my data. In the meantime, while they're transmitting data to the orbiter's transmitting instructions to the rover.
So it's a duplex, like you were saying?
Yes.
Okay, time for one more question. President?
What's the mass of your unit? Or how much does it weigh?
I don't remember off the top of my head.
2 kilograms.
Thank you. 2 kilograms. That's my boss's boss, by the way.
Very good. Okay, well, thank you very much indeed.
Thank you.